entry was Selene X-1, a pioneering moon mining camp. So take it away.
Good morning, everybody. I'm very happy and very proud to be in part of this presentation. Okay, I'll try to be brief, but happy to be in this presentation. For the purpose of today's presentation, I improved slightly what we have presented. So now it's called Selene X2. But anyway, we are on the far side of the spectrum. I mean, we're one of the participants, but I want to congratulate the creators of Domi Inter Astra. It's a wonderful place. I wish I could go there and win the lottery to be there. Anyway, this is a presentation, a very conceptual presentation. We know that we have skipped several of the elements that are required for being winners. However, we wanted to be here and to have a proposal for this. This has been done with a team of university students. They will be presented at the end, the Wildcat Moon Miners, all from the University of Arizona. And we are going to see a little bit of this concept and how the layout, how is the layout of this infrastructure and how it fits with the future operations on the moon. We have to start saying that we are mining engineers, most of us, and also we have a student from aerospace and mechanical engineering. And even though we are going to open this for all types of business and all type of activities, mining engineers have an experience on the earth, on remote places, remote locations, and the camps have some particular characteristics. Basically, well, living there, resting, some leisure for sure, and then continue working. Not terribly far from operations, and but it still needs to be a place for restoring. So this is some of the locations for this particular presentation. We chose the permanent shadow region areas on the South Pole, where the Shackleton crater is the closest to the South Pole, but there's a few others. Some of them are mentioned here. This is not made for a specific crater, but one of these areas for working. So the important thing is that we have to provide the proper sheltering to the operators, and later for a more permanent settlement, we can have visitors of different types, scientists, support, and for sure tourists, and we'll be happy to have them there. Another important thing is that we can have a better view of the firmament, the stars, and astral objects as well. Our name comes from the Titan goddess of the moon, Selene, as a slight modification, and it's a term where we use for anything related to the moon, as the Selenites from H.G. Wells' novel, and so on. Well, the deposits on the moon may be in the bottom of the craters. Some of them as huge as Shackleton or other craters. This is a very simple rendering of that, but also could be in flat areas around the craters. For this purpose, I have presented one for one crater. There's no specific definition of the crater, and the shadows have been removed to show how it will look whenever we start operations. In this case, if the water, or in this case the regolith or the icy regolith that contains the water, it's deposited at the bottom of the crater. And perhaps the first portion, the first 20 centimeters, will be a crust of no water, and then we'll have 1 meter of 4% water, and then 3.5 meters or so of 10% water, icy regolith. In any case, this material needs to be extracted and moved up to the outer to the rim of the crater, and that's the purpose of it. So with this, you see, that's one of the rockets that has left already. And we have this is a proposal for the mining camp. The operations will happen, as I mentioned, at the bottom of the crater, not on the surface, but a few feet or meters below the surface to avoid exposure to radiation. And it may have at least 2 components. The first one is a ramp that has to have around 6 to 10% of gradient for the equipment to arrive there. If we are using razors or similar type of equipment for extracting the material, or a sort of a continuous surface miner, or something that could work a few feet under, they can be held captive for the life of operations, and we can subdivide this surface in several sections, so we can extract them all, and then use a sort of conveyor system. We have one, our favorite is a rail conveyor. Is a sort of a series of U-shaped boats in where we can help up, move up the material. It works very good in snow, in ice, in soft material. So I think it will be very, very proper for extracting the material from the bottom of the crater and put it at the rim of the site. Here is a presentation of the site. We have a landing platform for the rocket. It's already gone, and the equipment that is going to help us for this. And here are several elements that were very simply displayed as a mechanical shop, warehouse, beneficiation plant. At the beginning, they could be also inflatable structures that could be later replaced for more stable settlements. And the home, the place for the quarters for living are represented here in a sort of a pyramid style constructions, and with the greenhouses, not too far from operations, but sufficiently away from any disturbance, perhaps with a nice panoramic view of the crater or some other place, with greenhouses and so on. We are including a monorail of some sort, so it would be like a mini Epcot Center. But the purpose is to bring comfortably the people from the headquarters, from the rooms to the working areas. This is a view that has been done by the students using SolidWorks of a rendering of each one of these pyramids. And the blue part is the one that goes to the surface, whereas the others are down below. The segments that are around are tunnels tunnels, and also declines to access to the lower parts of the building. Yes, we omitted some of perhaps the structural sound of the building, and we need to improve that. Our idea is to build this based on 3D printing, using the same regolith, perhaps the regolith that as all the water has been extracted, and also the crust that has no water at all. This is a section of one of the pyramids. Perhaps they may not have necessarily the same size, and depends on the amount of people, but basically the top part is we have to use the observation deck and communications and so on. And there are the portals and the access to the access ramps, and the portion that is below may have places like the dorms, gym, recreation, and so on, and the lobby, and then the basement for services, including some auxiliary equipment maintenance, and also all the systems for energy, water recycling, and oxygen, and so on. Of course, the greenhouses, and we're bringing these from the university's experience on the biosphere too, and the capability of creating these spaces for generating our own vegetables and places to stay. This is a kind of a plan view of the layout of the pyramids, how they are connected among them, and the greenhouses in the front, and the monorail ready to take people out. Very simplified, but at the same time try to be functional and useful. And this is kind of one of those conceptual views of the windows and how I don't know if this is exactly an accurate view of how do we see the Earth from the South Pole, but more or less wants to bring comfort and a view, a second home, as we mentioned. And we have also a special room, a big room in the lobby, or some place called One World. And we want to welcome all countries, all nations, all cultures, and all the diversity possible, and feel that we can be here all in harmony and working for the benefit of all humankind. Our logo also has in this case, the rim of the crater, and the pyramids, and some shadows that are showing the long shadows of the South Pole, North Pole, and so on. These are the Wildcat Moon miners. I'm proud to present them. All are undergraduate students, very passionate on moon mining. And we expect to do more and perhaps improve this to higher versions, Selene X-2 or higher, and include all the things that we wish a project like this would bring. I want to thank you, everybody, for the opportunity, and these are our this is our address, or my address, in case you want to communicate with the team. Thank you very much.
Thank you, Victor. This was great. I'm going to ask, see if there's any questions from the audience. Please, if you guys can use the Q&A panel to ask any questions you have, and I'll ask a few myself as well here. My first question, Victor, is how would you make this? I know the focus of this space is not tourism, it's mining. But if there were lots of tourists on the moon, how would you make this space appealing for tourists?
I think that the most important thing is that there's a fascination from people to be in places like this. Kind of, they would be perhaps attracted by the landscape, the craters, the view, perhaps a view of the Earth. That would be perhaps one of the most captivating feelings, to see the Earth from a distance, and also perhaps enjoy to some extent the odd cycle of light and darkness. If people is not too afraid from darkness, they could have also a view of the craters, the permanent shadow in the permanent shadow regions, and perhaps that would be kind of interesting for people to be enjoying perhaps the low gravity, and perhaps is fascinating the opportunity to see the change from brightness to darkness, and have a panoramic view of the crater or the craters, and especially the Earth. I think that would be an attraction for people. Just saying, oh, I went to the moon and I was able to see these things and feel comfortable, feel safe, feel that it's a great place, a workplace to see the moon itself and the Earth. And later, something that is possible to see, and the second is to create a platform for telescopes. Of course, you can see the results of this on different media, but being there and watching this observatory by itself could be another fascinating destination.
Yeah, I love the idea of a monorail. I remember riding the monorail at Disney World, and that was a lot of fun.
It's one of the best, huh?
Absolutely, and it's just perfect for the moon too. It'd be great to have a monorail on the moon.
Yeah.
How would you govern the settlement? How would you allow people to have a voice in what, the policies of the settlement?
I would start first to give priority, perhaps as a mining engineer, to the mining operations and the purpose of it. However, the settlement, the buildings may have a little bit more general, a more open space for people. I want this concept. I like this concept of the one world, and that people. That's a good question. For people to feel that they are in a common place, in a place of comfort, friendship, and collaboration, and that this place is not competition and one against the other, but everybody working in a common place. I may do an association with perhaps Antarctica, and I might fall short in that we have a common place in where everybody has opportunities to develop their work, the investigation, but promoting tourism, promoting science open to everybody for education also will be great places to create bonds and create motivation for the people to work. Now, it has to have a sort of an administration, the buildings themselves, like a sort of organizers or administration of these settlements for living purposes, like a sort of a lodging and catering type of organization, in where everybody is feels welcome and knows that they're doing their work. It's like a kind of hotel infrastructure or services that are associated to mining operations. They welcome everybody, but later they can provide whatever is required for operators, for vendors, for visitors, for scientists, and so on.
Okay. Question from Sean Moss. How far away are the landing pads? Because a huge amount of dust will be thrown up during landing, and it travels far in lunar gravity.
Correct. I agree with the problem. The concern of dust, I think, is one of the biggest ones. I think we better have a study of how dust settles on the moon. Meanwhile, I will have a prudent distance. We were considering from an exercise we did previously, at least 1 kilometer or perhaps 2. I don't want to have it that far because the extension would not be practical, and at the same time also being able to monitor or watching the landing of the moon of the rockets would be also appealing to the observers there. But I would say that, and I'm passing the monorail close to it, so at some point things, objects, and people that are coming there would easily go to their quarters. And so that would be my first attempt, 1 to 2 kilometers, but it needs to be a little bit more needs a little bit more of study. But yes, we have to know that if the headquarters are for resting, we can have a view of operations, but not too close to it. I mean, and vibrations and other disturbances also may happen. The position of the sun also may be considered as well.
Mm-hmm. Yeah, so I'm showing right now your Minecamp general layout. So you're saying the launch pad here would probably be 1 to 2 kilometers from the rest of the base. Would it be connected by that monorail too? Would you have like that be part of the design?
Yeah, absolutely. Yes, we need it. We need it because it perhaps will be the main one of the main uses of this infrastructure, bringing people and especially equipment. Much of this, the deployment of this equipment or packages or so could be done not by humans, but by automated robotic arms or continuous conveyor belts of some sort. However, eventually there will be also humans for supervision and people who is coming and going, and they may need to have a proper stop for it.
Okay. Next question from Manny Pimenta. Have you considered the energy needs? That's one kind of part of this question, the energy needs of the facilities and also the production rate of the mining facility.
Very good.
Yeah.
Very good. There are some preliminary plans to extract between 10,000 kilograms to 30,000 kilograms of water per year. Our preliminary plan and that we did for another project design is considering 1 Earth year. And this could be the goal. And this is based on the capacity of the extraction equipment. We are considering, for the moment, our favorite is the Razor, and the Razors can carry approximately 90 kilos of regolith. And even though we are not presenting here an actual layout of operations, we are considering that we can have cycles that would be more appealing to humans, like, for example, 8 hours or so. And then, but if some of this equipment is autonomous, they could go and work sort of unsupervised, and they could perform and extract this all this material, and that's perhaps one of the things. The other is the energy, and for energy we may need and there will be several sources, but one would be an energy plant located strategically not far from where we are working. Technologies could be many. Perhaps even it may sound kind of odd, but we can have a sort of a nuclear type of generation of energy to some extent. We might need energy for processes of the water extraction and some of the infrastructure that would require the conveyor belt and charging the equipment that works there, like sort of the Razors and others. However, we may use extensively, if possible, solar panels. They may work, of course, if these are permanent shadow regions, perhaps we can be limited to that. However, for sure, as we can capture as much of solar energy if we can. The building themselves will have smart capabilities to conserve energy, to recycle, and we may use also other elements. I don't know if the greenhouses may have sufficiently material for, say, biofuel or so on. We can recycle some of the materials that we have produce like waste or others. So that would be some of these sources.
I see. Okay, great. Well, thank you so much, Victor. I've got your slide up there with your contact info. If anyone would like to contact Victor, there's his email address, and congratulations to you and the team for working on this. And thank you for presenting today at the conference.
Thank you. Thank you very much, James. And thank you to all the Moon Society for the opportunity.
Awesome.